Hello, and welcome to my second video about ddwChucklib-livecode, which is the live coding system that I've been working on and performing with for about the last 5 years. This video builds on the previous one, so if you didn't watch it, you should go back and watch it now. I will put a link in the text. The topic today is generators. When I started making electronic music, one of the things I really wanted to do was to have every bar be a little bit different. And I used to do this in MIDI by hand. And when I discovered algorithmic composition, found that it was much, in a way, it was easier and more interesting to try to imagine like how to get this. And so generators are a way of expressing that. Let me load the system as in the last video, and okay, good. We're all correct. Okay, so let me give a little background about generators first. It may not be obvious at first, but every item, every element within one of these sequences occupies a span of time, which in the manual I visualized using some graphics. So if we take a simple pattern string with a drum stroke on beats 2 and 4 and another one in the middle, it is not only that they start in these positions, but the item actually extends all the way through to the next one. And we can actually prove that by putting this pattern into a snare drum player. The syntax for finding these items is not convenient. It doesn't really have to be convenient because you don't have to look at this generally. But if I run that, then we can see exactly that these times for each item are correct, and also the durations. So for a single note, that's not particularly interesting. For a generator, a generator performs some process within the time span, and the beginning of the time span can actually affect how it behaves. So for example, if we have a generator, which here the meaning is to place 4 of these things on any available 8th note within the span. Well, how do you know what is an 8th note? You have to start from the beginning of the time span, and then these highlighted time points are where it may insert. Okay. Example C shifts the insert by an 8th note and also asks for quarter notes. So now these are the available positions, but not number 4, not the end of 4, because there's another element that is not the generator to take up that space. So the time span of this one can only be within those 2.5 beats. We may talk about fork a little bit later. But I would like to dive into that. Okay. Chucklib-livecode generators are not the same as SuperCollider patterns. So patterns are processes that unfold sequentially. A generator works on the material within the part of the bar, and it can add elements into it. It can modify those elements, but currently there is not one to delete an item. But to be honest, I haven't really needed it that much, so I haven't written it. And the way generators work together is one generator modifies the sequence in the bar, and it can modify in any order that it wants. Then the next generator in the sequence will take the data prepared by the previous one and operate on that. So let me actually with this, and I'm also, because metric position is important, let me make a simple metronome. Remember, this is up an octave and normal octaves. So if I play this, you will get, okay. It will cut through a little bit better if I bring up, I'll use my MIDI controller, bring up the filter just a little bit. That sounds better. Okay. Now, if you're going to get tired of this. All right, and let's have a simple melody player, just a basic analog style pulse lead patch. And I will put in just a very simple pattern. Okay, yeah, I'll do it this way. Just on quarter notes for now. So if I run these together, put the filter up a little bit. All right. Okay, so for every beat, now it is randomly choosing one of these notes. Let's actually let it use the whole scale. Okay. This is very unstructured. One of the ways that I give some more structure to the phrase or the bar is to have some fixed elements in it. These have to be provided as a what I call a source string. So, and a source string is enclosed in brackets. So if we take this generator, copy paste, let me put at the beginning of the bar, we'll just put an octave down. Okay, that's a little bit of structure. Let's put a couple of low notes off the beat. Right. So this part is constant, and it is fed into the insertion by the use of this double colon operator. The double colon operator is a chain. And you will see in my videos that I sometimes have very long chains of generators. You know, generator, 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 generator. The chains can be as long as you want them to be. Okay. I guess these source patterns in brackets are also, you can nest them. So you can have a source for the whole bar like this, and then have part of it for another source and another generator. You actually have quite a lot of control in that way. All right, let's talk about a couple of kind of usage patterns then. We've been looking at the insertion. At insertion based on a grid, which again the time span matters. So if we have here just on quarter notes, we saw how you can use these placeholders to affect timing. 3, 4, 1, 2, 3, 4. Right. So as before, here we have one item, we have a second item. The bar is divided in half. if we want that to be an eighth note offset, we need to put them, to confine this to be in the first beat. And now these are offset. And you will start to hear the PL as the downbeat instead, but we can fix that. Okay. Some other ways to generate rhythm are we can do a weighted selection. So let's take the same thing. And let's say we want to choose from multiples of an eighth note. So let's have a small probability of an eighth note, a larger probability of a quarter note, a dotted quarter, and maybe half note. Yeah, let's allow a little bit of half note too, okay. Okay, a rhythm with a little more character to it. Some other things that figure into my work a lot. Choke pattern, which will, well, let's listen to it first. Okay, so it just finds an item, and then that amount of time after we'll put something else into it. Here it is a rest. It could be something else. Let's go up to a ninth. Right? Oh, that's actually kind of fun. But we'll go back to the rest for now. Okay, I think we can also, let's do this one, stutter. For time, I won't do all of the details here, but let's take one of these notes and do it every 16th note. And if I don't supply anything else, it will simply. So it's chosen one of the notes in the bar, and it's just repeating it. That will get more interesting when we get into these wildcards. So, early in the development, I kind of struggled with what generators should do, and eventually settled on this pattern of inserting wildcards and then filling in the data later. This gives you the option of controlling rhythm and content separately. So let me rewrite this. We will take out the stutter and put in a wildcard. Now, when I play this, you hear nothing because the wildcard is not a valid is not a valid pitch to play. But we can chain onto this a sequence. So let's do a sequence. Let's get the metronome back. Okay. One feature of this is that the sequences do not have to reset at the bar line. So that's one way that I sometimes get polyrhythms for basically for free. If I do random, that should sound familiar. That should actually sound exactly like this. But you do have some other choices taken from the pattern library. xrand, which will choose randomly, but it will not play the same one twice in a row. Or one that I use a lot is shuffle. So play all 8 of these in a random order, then choose a different random order, and so on and so forth. I use this one quite a lot. Okay, I'll change my plan a little bit. You can use modifiers to apply an articulation. So now they are all staccato notes, or you could have, for example, 2/3 probability of a slur and 1/3 probability of staccato. And one of the things that I find really powerful about the wildcard approach is, for example, let's all right, I'm going to do this a little bit differently. Let's insert randomly 2 or 3 at 2 or 3/8 notes, one of these, and let's get rid of that. Okay, we can consider these to be like structural notes, and we can make them accented and slurred into the next. So you can hear the accent, right? All right, and then let's insert a different wildcard, and let's just fill up the whole bar with it and do a shuffle. Now we need to tell it to use the different wildcard, otherwise it won't pick that up. But let's put in something like that, and we should actually slur those. Okay, so now we have like sort of a 2-layer melodic pattern with some articulation in it too. And we can even up the ante a little bit and go to maybe raise the fast 16th notes up an octave. Okay, so that's kind of fun. I mean, I can play with that for a while. Okay, what else was I going to do with that? I even just added a feature the other day where we could take the, let's have fun with this. Let's take the structure notes and make a chord out of them. Yeah, this is where I kind of have some fun with it. Okay, and then there's one other thing that you can do with this type of generator, which is actually to nest them and build more complex structures. So, tell you what, I'm gonna take the chord out because I think it's a little distracting. Now, let's say I want, let's start with a sequence following this. So instead of randomly jumping around, we should get okay, that's better. Right. Okay, let's say that I want to do this pattern 3 times and then a different pattern once. Well, we can write a sequence containing this sequence. Now it will not sound any different, but let's put in a different sequence, maybe a descending pattern. Okay. Why is that interesting? Well, let's say we want 2 to 4 times going up like that. Okay. Right. So now the pattern has some more variety and some more character to it. These are actually modeled after the normal SuperCollider pattern operation. Okay. There's one more topic that I want to talk about, that if we go back to this sort of pattern, one challenge in the design is that this generator here does not have any access to the first eighth note. Well, we don't want this generator to, but what happens if you change something else onto it? And in fact, I'm going to go to a hi-hat to demonstrate this. So let's take hard hi-hat, put 1 off the beat. Yes, like that. Okay, so these are off the beat where we want them. That's fine, but what if we want to fill up the bar? 0.25. And there's a hole at the beginning of the bar, right? Okay, let me put this up here so I can get to it. Okay, the reason is that the chain takes its time span from the first item in it. This insert does not begin at the beginning of the bar. Therefore, the chain cannot begin at the beginning of the bar. So we have a problem. We need this one to be offset, but we also want to have access to the whole time span after that. So the solution in this system is a generator called fork. So if I put a fork in here for the whole bar, what is inside the fork? Well, inside the fork is another interpretation of this span of time, and I can take the generator and put it off the beat. So inside this part of it, it behaves exactly like this, and it will operate only within its own time span. You can even close off an X. Because this is not a generator, this will do nothing. It only defines the time span. Fork itself occupies the whole bar. So if we now put in this generator to fill the bar, and we play that, let's get the metronome going. Oops, wrong button. Okay, and now so this second insert is operating on the whole bar. I actually do this quite a lot for hi-hat patterns. So I think I've talked long enough for now. I want to keep these videos to some reasonable length, so I will stop there. If you are interested, check the Chucklib manual has an entire chapter about generators, listing all of the generators. It does take some time to learn to think this way, so so be patient with it. But But it's really a lot of fun. I mean, it cannot do everything that SuperCollider patterns do, but you can do a lot. And I really enjoy working this way. So thanks for watching, and hope this was interesting to you. And I look forward to expanding on this at the next opportunity. Okay.